Hi guys, and welcome to our next part of the lesson. So, you'll remember we've done compounds so far. So we have done the molecular compound and ionic compound. So ionic is metal with a nonmetal, and molecular is nonmetal with a nonmetal. So this one today is polyatomic compound. What is a polyatomic? Yes, that. A polyatomic. Well, I'm going to let you know. A polyatomic is a sort of ion, and it's kind of like a couple chemicals or a couple elements put together. So in a way, it's actually a compound, if you kind of want to look at it. So I have this sheet here. I'm going to let you look at it. So if you need to, I'll take it out of its protective paper, just so you can get a good look at it. If you need to, please pause the video now, just to get a good look at this left column here. So down here is where you're going to need. So as you can see, it says polyatomic, and these are all the ions. So as you can see, if it's like if it's not on your periodic table, because I do have questions on these. If it's not on your periodic table, this nice, beautiful piece of artwork, then it's probably going to be a polyatomic, just to let you know for the questions. If you can find a cheat sheet of some sort, that'll be perfect. Use your cheat sheet and solve these questions for the polyatomic. Anyways, moving on to what are polyatomics and how do they work? Well, I'm going to try and keep this short, so if you listen fast, I'll talk fast. We'll be done quickly. So, first, to start, polyatomics is one of these complicated things, but it's really not that bad. So all it is it's a normal compound, just adding a polyatomic. So I'm going to do two demonstrations, and then I'll let you get to your questions. So first, we're going to do sulfate, which is kind of like sulfur, except a different version. So sulfate is S. Oh, and these are all gas. Sorry, these are all act as non-metals except for ammonium, which is at the top, and it's NH4. So we'll start with that one, actually. So we're going to go NH4. So this is kind of like an ionic, except instead of ionic, so instead of just a normal metal, which is like, we're going to use polyatomics, which are more interesting, and they got bigger letters. So, NH4 stands for ammonium. And then we're going to add that, because there's no charge to it, we're going to add it to iodide. Iodide. So iodide has one charge and ammonium has one charge. So that's all. So it's just NH4 plus I equals NH4I. That's all, right there. That's it. So as you can see, it's just like an ionic, except we're just using different letters. That's all. So last one, and this one's going to act like a gas. So as I said before, I'm going to do sulfite. So this is one of the more, or actually sulfate. 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 This is one of the more commonly used polyatomic compounds, so you'll probably, by the end of this, memorize it, or hopefully. So we're going to start with calcium. So calcium. So this is Ca. It's a metal. And I'm going to do metals or ionic or ammonium in green, and I'll do non-metals or the rest of the polyatomics in blue. So we're going to do calcium plus what did I say? Sulfate. Sulfate. So sulfate is SO4. Now sulfate has a charge of 2. And calcium has a charge of 2. Yet, because normally you're going to do what's called a crisscross applesauce. So this 2 is actually going to go over here, and this is going to steal it. And this 2 is going to go over here, and calcium's going to steal it. But because they're both 2, they cancel each other out. So you're left with SO4 Ca, or CaSO4. And that, well, it just equals Ca and then SO4, so just no plus sign. And that's all. So that's how to do polyatomic compounds. I hope you have a good time with the questions. Good luck, and see you next time.